Think about it. We spend almost all of our time inside buildings. We live in them, we work in them, we pretty much trust them with our lives. And yet, these things are massive, impossibly heavy structures just soaring into the sky. So, have you ever just stopped and wondered, why don't they just, fall down? What's actually stopping these giants from sinking into the ground or tipping over? Well, we're going to dive into that because the answer is this incredible story of engineering that's happening literally right under our feet. Okay, so it really all boils down to this constant invisible battle. On one side, you've got the building's immense weight, with gravity just pulling it down, down, down. And on the other side, the strength of the ground itself, the geology. And look, if that ground is weak, the building is going to lose. Simple as that. The secret weapon, the thing that wins this fight, it's hidden completely underground. We're talking about the foundation. All right, so how do these things actually work? Well, for a lot of buildings, where the soil near the surface is pretty solid, engineers have this really clever strategy. It's actually pretty simple. They just spread the load. The absolute best way to picture this is with a snowshoe, right? When you wear a snowshoe, it takes all of your body weight and spreads it out over a huge area, so you don't just punch right through the snow. A shallow foundation, it does the exact same thing, but for a whole building. It distributes that massive load so the building doesn't just sink into the dirt. And you've probably seen these kinds of foundations without even realizing it. You've got the super common concrete slab, which you see a lot in warmer places. Then there's the crawl space, which basically just lifts the house up off the damp ground. And of course, the basement, which is a must-have in cold climates to get the foundation below where the ground freezes. They're all just different ways of being that snowshoe for a house. But what if the ground at the surface is just bad? Like soft clay or loose sand. A snowshoe doesn't really work on mud, right? So what do? Well, engineers have to completely bypass that weak stuff by going deep. And this is where we get into what are called deep foundations. So forget the snowshoe for a minute. Now I want you to picture massive stakes being driven deep into the earth. One type is called an end-bearing pile. These are basically long, strong columns that punch right through all the weak soil until, bam, they hit solid bedrock. Then the entire weight of the building gets transferred directly onto that unmovable rock. It's pretty amazing. Okay, but what if the bedrock is just way too deep to get to? Do they just give up? No way. Engineers have this other incredible trick up their sleeve: friction piles. Now get this, these piles are held up by literally nothing more than the powerful squeezing grip of the dirt around them. It's the friction all along the sides of the pile that holds the whole building up. I mean, how crazy is that? It's just mind-bending stuff. So you've got all these options, right? Spreading the load, going deep. How in the world does an engineer choose the right one? Well, it is one of the single most critical decisions in the entire project. Because man, if you get this wrong, the consequences are huge. Engineers have a whole checklist they run through. They're looking at the climate, the budget, obviously the size of the building. But the number one absolute non-negotiable rule is this: know your soil. Everything, and I mean everything, starts with understanding what kind of ground you're about to build on. Because when you don't, well, you get this. The Leaning Tower of Pisa is probably the most famous foundation failure on the planet. Why? They built it on soft, unstable soil with a foundation that was just way, way too small for the job. The lesson here is practically etched in stone. Investigate the ground before you build. Or you get this. This is the Transcona grain elevator. It collapsed the very first time they filled it up. Can you believe that? The engineers designed a foundation that was perfect for an empty building. They completely forgot to account for the massive weight of all the grain that would go inside. It's such a harsh reminder that you have to design for the building's maximum potential weight, not just what it weighs when it's empty. So when you really step back and think about it, the foundation isn't just some boring block of concrete under a building. It's so much more important than that. It's kind of like a hero, constantly at work, but completely out of sight. It really is the unseen hero of our modern world. It's a true masterpiece of engineering, fighting that silent battle against gravity, day in and day out, so that our buildings, our homes, our entire cities can stand tall. And that is the fundamental reason why, almost every single time, buildings don't fall down.